Hello, everyone. Welcome to The Extraordinaire. In today's episode, we're going to be looking at more control flow tools. But before we get into that, I'd like to give 4 recommendations on how you can make your learning a little bit more productive. It is something that has helped me over the years, and I believe it's going to help you out too. So let's get into it. The first recommendation is you ask questions. If there is anything that you do not understand, if there is anything that is unclear or confusing, make sure you ask questions. If you do not ask questions, they will remain confusing and unclear to you. Use the comment section, ask questions, and when I encounter such questions, I'll do my best to answer them, probably in a separate series. Pick an ideal environment for learning. This is the second recommendation. You shouldn't be learning while you are in transit or where there is so much noise, where you are being distracted. Usually, I learn when my family members are not around or during the late hours of the night when everyone is asleep, where everywhere is very quiet, so there is no chance for me to be distracted or disturbed. I think this is something that is going to help you a lot as well. The third recommendation is practice. You have to practice what you are seeing in these videos. Don't just watch the videos. If you see me type anything on the terminal, try also to type the same thing and try to get the same results. When you don't get the same results, if you can also ask questions about it, why you are not getting the same results. The last point is you need to tell someone about what you are trying to do. I believe that everyone that is following me on this journey is also has the same goals as I do, which is to eventually become a data engineer with Python. So it would be beneficial for you to tell somebody that can help you to stay on track, somebody that can keep you honest, somebody that can keep you accountable. This is very important so that you don't just start and stop halfway along the way. This is very, very important because we as human beings, we don't like to be seen as less in someone else's eye. So pick somebody that you respect, pick somebody that you can hold you accountable, and tell them of what you are trying to do. This is going to go a long way to make sure that you complete it. Those are the recommendations. I believe they are going to be very useful. In the last episode, we touched a little bit on the while statement. But apart from the while statement, there are other statements that can be used to control the flow of a program. And one of such statements is the if statement. This if statement is perhaps the most well-known statement in almost any programming language, and Python is not different. Let's see how it works. We have the if statement, the initial if statement. If x is less than, hold on, let's first impute the first line. X is equal to int impute. Please enter an integer. What's wrong? Impute. Oh, I typed in the wrong thing. X is equal to int impute. Please enter an integer. Right. Let's impute the integer. Then we write our code. If x is less than 0, x equal to 0, print negative changed to 0. If x equal to 0, print 0. If x equal to 1, print single. Else print more. Cool. As we can see here, the if statement has multiple parts. We have the if, we have the elif, which is a short form of else if, and then we have the else part. An if statement can consist of one of the if statements, one or more elif statements, and then the else part is optional. Although I believe that the if statement can also stand on its own. Let's say that if x is greater than 0, print yeah, the if statement can stand on its own. These elif counterparts are there to help you look at other options. Is a substitute for switch and key statements in other languages. If you are comparing the same value to several constants or checking for specific types or attributes, you may also find match statement useful. We're going to look at the match statement in a subsequent episode. But this is how you write if statements. Let's move to the next one. For statements. The for statement in Python differs a bit from other languages. Rather than iterating over an arithmetic progression of numbers or giving the users the ability to define both the iteration step and the halting condition, Python's for statement iterates over the items of any sequence, a list or a string, in the order that they appear in the sequence. So what this is saying is, in normal programming languages, you would have something like this: for I is equal to 0, I less than let's say count of a certain number, like of a certain list, like let's use items, then I plus plus. This is how you define for loops in most languages, but Python is different in the sense that it doesn't need this syntax for defining a for loop. You can just loop through any sequence, whether that be a list or a string. So let's see an example of that. Funny enough, I've learned how to clear the screen without exiting the terminal. So what you do is you import OS and then you type os.system clear like this and hit enter. If you're on a Windows system, it will be system CLS like this, and then you hit enter. I'm on Linux, so I use clear and it clears the screen. Let's take a look at this for statement example. Words equal cat, window, defenestrate. for W in words, print W, len W. We saw in a previous episode that len tells us the length of a string. So this is going to give us the string and the length of the string in this list that we defined above. And then we have it. Cat has 3 letters, window has 6 letters, and defenestrate has 12 letters. Code that modifies a collection while iterating over the same collection can be tricky to get right. Instead, it is usually more straightforward to loop over a copy of the collection or create a new collection. So, if we are trying to work with a collection of data, it's going to, sometimes we may need to modify that data as we are working with it. It's going to be very difficult to do that on the same piece, on the same collection, right? It's going to be very tricky. So it will be better for us to either get a copy of that collection and use that, or we can create a new collection and assign whatever we are working, whatever processes we are doing, assign it to that new collection. So for example, we have users. I'm going to say Bill is active, and then we have James is inactive. We have, let's do Bob is active. Define the user list. If we display this user list, we say that it has all the elements in it. For the first example of copying the elements first, we use this syntax. For user, status in users.copy.items. If status equal inactive, delete user. Let me explain this code. For user, status is a multi-assignment. So what's going on here is that the user here is the index of the collection, and then the status here is the value. Okay, so this build here becomes the user, and active here becomes the status. And then we check if status is equivalent to inactive, and if that is true, we delete that item from the collection. So let's proceed. Now if we display users, as you can see, the inactive James is no longer part of the list, is no longer part of the collection. This is one way that we can work with a collection, while we can modify a collection while we are iterating through it. Another way we can achieve this is, first let's redefine this collection users. We can create a separate collection. Let's say, for example, active users. Now we can loop through this the same way we did before. let me explain what's happening here. The difference between this example and this is, in this case, we don't need to copy anymore because we've created a different collection where we are going to be assigning the new values. So we just loop through the items of the users list. We check if the status is equal to active, and then if that is true, we assign that status to the new collection using the name as the index. Now let's proceed. Now that we've done this, if we come in and display active users, we see that active users are displayed without the inactive user. If I should display users, we still see the inactive user there. So what this does is it maintains the original collection and creates another collection that you can now work with. That's how you do that. Let's proceed. The range function. If you do need to iterate over a sequence of numbers, the built-in range comes in handy. It generates arithmetic progressions. Let's clear this. Since Python doesn't do the regular for loop, which usually provides an arithmetic progression, it uses range to achieve the same result. So for example, I in range 5, print I. This prints every number starting from 0 up to 4. The given endpoint is never part of the generated sequence. What that means is that for this range 5, we are starting from 0. So we are going to do from 1 up to 4. 5 will not be included. Even though by so doing, we get 5 elements, 5 items from the sequence, it's not including the last item. So this is something that you need to take note of when you are working with range, and it determines the number that you are going to impute. Remember when I was in school, our programming lecturer gave us an assignment that had to do with accepting an input of a matriculation number and then printing that input 10 times. I knew how difficult, how challenging it was to achieve that at the time with C++. But with Python, we can do something like this. For example, we say x equal int, or let's not say int, let's just do input. Enter your matriculation number, and we can say blah 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 and hit enter. Now we can print this 10 times by doing for I in range 10 print x. And there we have it. Very simple and straightforward. Really nice. It is possible to let the range start at another number or specify a different increment, even negative. Sometimes this is called the step. The range allows us to change the starting point of the sequence of numbers. For example, list range 5, 10. This starts from 5 all the way to 9. Remember, the last number is not included in the sequence. Normally, if we do just range 10, we get 0 to 9, but we can decide to impute the starting point. In this case, we are starting at 5, and so it starts from 5 instead of 0 up to 9. We could also decide to put in a step, so this tells us the interval between numbers. So for example, we could say start at 0 and then leave a step of 3. So this will give us 0, then it counts to 3, then counts another 3, that is 6, and then it counts the last 3, which gives us 9. We can change this as well and say start from 1 to 10 with a step of, let's say, 4, right? So it starts from 1, the interval is 4, so the next number will be 5, and after that the next number is 9. It doesn't have to always be positive. We could decide to use negative numbers as well. So let's see this example: -10, -100 with a step of -30, and we see it gives us -10, -40, and -70. To iterate over the indices of a sequence, you can combine range and len as follows. Let's say we want to display a list and its index. We want to display items in a list and their indices. We can do that using a combination of range and len. Let's see how that works. So we say Mary had a little lamb. All right, Mary, had, a, little, lamb. For I in range, len a, print I, a, I. This I is the index of this list. So for I in range, len is going to give us, len gives us the length of the list, which is 1, 2, 3, 4, 5. So we are going to get a sequence from 0 to 4. Remember, the last number in the range is not included in the sequence. So we'll get a sequence from 0 to 4. So I will take values 0 to 4. For each iteration, I will be a different value of 0 to 4. So we have I as 0, I as 1, I as 2, and so on, all up till we get to 4. So we print I, and then we print I, AI. We are using I as the index to get the value or the item from the list A, which gives us the items, the individual items in this list. And there we have it. So the first index item 0 is Mary, index 1 is hard, index 2 is A, index 3 is little, and index 4 is lamb. In most such cases where we need to do something like this, it is convenient to use the enumerated function. I guess we're going to see how to work with that function in a later episode. A strange thing happens if you just print range. Let's see what happens. Before we do, let's clear the screen. It's getting filled. If If I just print range, this is what we get. In many ways, the object returned by range behaves as if it is a list, but in fact it isn't. It is an object that returns the successive items of the desired sequence when you iterate over it, but it doesn't really make it a list, thus saving space. We say such an object is iterable, that is, suitable as a target for functions and constructs that expect something from which they can obtain successive items until the supply is exhausted. We have seen that the for statement is such a construct, while an example of a function that takes an iterable is sum. What this is saying is range itself is not a list. It doesn't return a list, and the reason for that is to save space. Instead, what it does is it returns successive items in a sequence in a way that behaves like a list. So it behaves like a list. It's cosplaying as a list, but it's not actually a list. Okay, and that is enough for most functions that require a list-like value, and such list-like elements or such list-like objects are referred to as iterables. So that's what this is trying to say. Range doesn't return a list. It is not a list in itself, but it behaves like a list. Let's see this sum example. Oh, I did 10 instead of 4. Very good. We have 0 plus 1 plus 2 plus 3, and that gives us 6. Later, we will see more functions that return iterables and take iterables as arguments. In chapter data structures, we will discuss in more detail about lists. We're going to stop here in this episode, and in the next episode we'll continue from break and continue statements. If you enjoyed the content, please like and subscribe. Share with anyone that you think is going to like it as well, and I'll see you in the next one. Bye.